Hello, dear colleagues. This is the third representation on chemoinformatics, and today I would like to discuss the concept of molecular descriptors. Let me introduce myself. My name is Professor Sergey Shityakov, and I'm a head of chemoinformatics scientific group in Infochemistry Scientific Center, ITMO University. And what is the chemical molecular descriptor and how we will implement these descriptors in chemoinformatics? The molecular descriptor is some kind of a value which was calculated by using different chemoinformatics techniques for the particular molecule, whether the molecule is in order to analyze the molecule to develop it in a more potent medication to treat different diseases. And on this slide, I would like to give you some example of different molecular descriptors, such as topological descriptors, atomic charges, inductive descriptors, molecular volume descriptors, and different descriptors which are describing molecular surfaces. That is why one could simplify this term as a value which describes the property of the molecules, such as on this graph, where we are trying to describe all the particular physical chemical properties to come up to some unique descriptors, and these descriptors can be used in a chemical space analysis. And this particular descriptor sometimes called molecular fingerprint, these unique descriptors. Therefore, one could say that these descriptors are particularly useful for the chemical space analysis. And today, we have approximately 5,000 types of different descriptors. Some descriptors are classical descriptors, such as molecular weight descriptors. The other, they are more advanced descriptors or more unique descriptors, or they are still in a development phase. In our group, we are also working on different algorithms to devise new descriptors, such as Voronoi descriptor and Shannon descriptors, which might be particularly useful for the chemical space analysis. And here I also would like to give you the introduction on some descriptors which represents the core of the molecules. And these descriptors are called the molecular scaffolds. Now, what are the molecular scaffolds? The molecular scaffolds describe the core structure of the compounds or a series of compounds, usually position site of chemical variations in the core structure carries a different substituents functional groups, R groups, in different analogs. And these scaffolds are very important if we would like to screen very big chemical databases in order to find similar substances in terms of the molecular scaffolds. Sometimes these scaffolds are also useful if we will try to modify the molecule. So we know that some group of the molecules, chemical substances, have this unique scaffold, then we can use it to add some other groups like methyl groups or propyl groups, hydroxyl groups, etc., to improve the interaction of these molecules with some biological entities such as proteins. And on this slide, I would like to give you the information on our results, which are published, where we trying to come up to some molecules to inhibit the corrosion activities of some acids on the metal surfaces. And for some molecules, the benzotriazole score is a kind of a unique score, a unique molecular scaffold, where we could analyze and compare this information with the experimental results as corrosion inhibition values to develop something like quantitative structure activity relationship models. This model is particularly useful if we don't have the information on the corrosion activities for some unknown substances. Then we can take this model and calculate the corrosion activities for some molecules that we could try to develop for these particular purposes. The other concept of a molecular descriptor is the pharmacophore model, and pharmacophore model is also a very useful descriptor or technique where we can implement to analyze the chemical space and screen through various of drug-like molecules to find a better candidate in terms of the binding. On this slide, you have two molecules. One molecule is a oligopeptide, and the other molecule is a drug. And these molecules have very similar pharmacophore model, but they have a very different in terms of the structure. Therefore, we could also utilize this pharmacophore model to search for some kind of similar substances in terms of the bioactivity. And how we can process or analyze the pharmacophore. Here is an example. We will implement the geometric analysis of this pharmacophore structure. And usually the pharmacophore structure represent some kind of active centers, such as hydrophobic interaction center, negative charge center, such as hydrogen donor center, and hydrogen acceptor center. And by using these centers, we could create some triangle and analyze the distances between these three centers. And the distances are similar for both of the substances, which concludes that these two molecules might be very similar in terms of the bioactivity. There are also some more sophisticated pharmacophore models, and here's the example. There are some pharmaceutical companies, the private pharmaceutical companies, and they are developing more sophisticated pharmacophore models, implementing different centers, active centers, such as negative ionic fields, positive ionic fields, also hydrogen bond acceptors, hydrogen bond donors, hydrophobic or hydrophilic fields, active center, and sometimes they also integrate in some lipophilic centers, which are based on the pi-pi stacking mechanism or similar molecular mechanisms. This is all for the introduction of the molecular descriptors, and thank you for your attention.